very excited to speak here in Data Innovation Summit. And what I would like to share with you today is some ideas and experiences I have got when building AI capabilities for our company, Stora Enso. And the topic of my presentation is AI platform for large-scale manufacturing industry that is relevant for our company. But of course, many of these things I will discuss are general enough to be applicable in other domains also. So I love to start the presentations by defining key concepts I use frequently in the presentation. And in this presentation, I start by defining what I really mean when I'm talking about the AI platform. And then one key element of this AI platform is an AI-based service, and especially in this case, when there's a lot of discussions and a definition game related to AI, it's really important to define what this actually is, AI-based service. And then I will go through some challenges we have faced in at Stora Enso related to data and AI-related things. And then comes to the actual beef of the presentation, how we have met these challenges. And finally, I will conclude the presentation by emphasizing some key points and hopefully also offer some takeaways for the audience. Yes, so about this AI platform, at first I have to emphasize that it's not anything, this kind of monolithic service for AI-based applications, but it's more like this kind of set of architectural guidelines and tool recommendations, even some concrete tools for supporting these AI-based services during their whole life cycle, starting from actual development work to deployment to the production, testing, maintenance, even providing some visibility to functioning of these services. And of course, we are talking about AI. It's really closely related to data, where we are trying to get some insights from the data or to training some models, doing some control based on the data. Data is a really important element in our company. There's a lot of different data sources. And it would be really burdensome to try to build this kind of separate data pipelines for each applications. Instead, we have built a centralized data repository. We are collecting this data to the same location so that it's easily available for all the services. Of course, when you have this kind of centralized repository, one requirement is that the data should be pretty automatic in its nature. And when you have this kind of automatic data, it's not directly applicable to practically any applications. So we should have also this kind of serving layer. And the serving layer, it contains different kinds of repositories like SQL databases, key value stores, a lot of different things. And these three components, this left-hand side architecture, it's practically a data pipeline. And of course, there's a lot of options how to actually implement this, but I think that you can find the similar architecture also from any data-driven organization. But then comes this actual focus area of this presentation, this analytics platform, and it's something that is the place where we orchestrate all the services based on data and analytics. And it is something that is really rapidly developing field. Well, listening to these previous presentations, there's a lot of related topics. And yeah, there's a lot of options there, even some internal internal development work inside our company. Then the last thing is the presentation layer, is how the end users actually interact with these analytics services and the applications we have. We also have some cases where we do actual controlling of some real production lines or related things with analytics, but it's also part of this presentation layer. Okay, then let's go to this definition of AI-based service. There's a lot of discussion around this topic, so usually when I'm using the abbreviation AI, it can refer to artificial intelligence, augmented intelligence, but I will take this kind of really practical approach here, so that AI-based services are services where the central concept is model. Services that have one or more models, and that these models are objects or functions that perform input-output mapping. So that they're this kind of pure functions, you put some data in and then they output something. And examples can be that these inputs are, for example, previous observations in some time series and the output is the prediction, or they can be some image detection systems that the input is image and the output is an image class. But practically, the actual implementation of the model can be anything. It's very simple, very complex neural network, so on. But currently, what we have, one way to define is that we have mainly statistical models. And the statistical models, because neural networks are also the statistical models, then this kind of standard statistical models. One important thing is that they have this model class. Then we have some free parameters, and we fix these free parameters by using training data. And this captures, because these models are statistical in these natures, they capture statistical properties of this training data. And this is really important thing because it also means that when they are used in the production, this input data to the model should share the same statistical properties as this training data. And this is really important issues when deploying this kind of applications. Then I will shortly go through the major data and the AI-related challenges we have at Stora Enso. One thing is this high data volumes and the data variability. So we have a pretty high data volumes. They are not exceptionally high, but pretty high, since that considering that roughly we can categorize this data assets we have to two categories. One is this kind of really low-level data coming from our production lines. We have about 40 different production lines. We collect something like 200 terabytes per data per year. I estimate that we are currently collecting about half of the available tags. So it can be also estimated this will double in the near future. But then, in addition to this kind of low abstraction level sensor data from the production lines, we have transactional business related data like all other companies related to customers, products, invoices, orders, this kind of standard data. But we are mainly playing in the business to business field, so the volumes of this kind of transactional data is not so huge. Then other challenge we have is the quality of the data. You can imagine it's really easy to imagine that when we have mills in different countries, in different continents, there's this infra-related challenges, some data blackouts, related things. But what is more difficult issue is that the statistical properties of this data will change. There's this kind of really slow changes like aging of the sensors, configuration changes that we replace some sensor units with from other manufacturer, calibration change, and at the same time the statistical properties change. Human errors, and only part of these cases we get to some kind of notification that this will happen, and that therefore we should have automatic means to detect these. Then we are heavily multi-vendor environment, operating in 36 countries. It's estimated that we have about 400 vendors working for our company, service providers, system providers, software vendors, so on. Okay, then still one challenge, and I put it in the separate slide because it's a kind of different kind of challenge. I would say that it is AI ethics in practice, so that the AI-based services, like other services and the data, they should have an owner, some person who is responsible for observing how the service is functioning in practice. And when you have such a responsibility, you should have also the means to fulfill these responsibilities, to carry out the tasks you should do. For example, getting feedback, observe how it's functioning, and to take right action when it is needed. And this is one thing, we should have a visibility to our AI-based services. So then, really, as an appetizer for this actual AI-based services, and why I define it like that, is this kind of short timeline, how things have in a company. Originally, the situation was so that we had a lot of vendors that were offering their services from their own private clouds, and they were actually collecting data from our mill business units, our production lines, and we didn't even have access to these. Nowadays it's a little bit different. We have our own cloud architecture, and we are doing the data collection, and vendors are providing the services to our cloud architecture. Practically it means that they are running as a container-based systems in our cloud. But we would like to have it even further, so that we are working hard to get our legacy assets to the same cloud, so that it's easy to build a new AI-based services. And we also would like to separate the service logic and models. And why we would like to do that? It is because the service logic is actually something, remember this architectural framework I showed in the first slide, is something that get the data from the serving layer, transform it in the format that can be put into the models, and then these models do this the job, they map it to the output, and then the service logic again takes the output and provides this presentation layer. And then when we have this kind of separation, and the service logic is in a separate place, these models, at least we have a visibility there. We know that what models are there. We can add proper metadata to the models, for example, version information, information about the statistical properties of the training data. Remember this definition of AI-based services, so on. And one important thing, when they are separated, you can put something between the service logic and the model. And what is the natural thing to put there is just kind of model validation service. When we have this proper metadata available, we can utilize this metadata so that we continuously observe what goes into the models, and if the statistical properties are differing enough from these properties of this training data, then we can start something, raise flag, model retraining, things like that. And then how we actually orchestrate this whole thing is that we have divided this AI-based service management, this kind of AI resource, groups. And this research group, it can be something so restricted, like one service-related, service-level research group. In practice, it's something little bit broader, some unit-level thing. But the important thing is here that this research group, actually it contains all the needed services. We have a container service, Kubernetes cluster or something that is running these actual containers containing this service logic and the models. Then we have a container registry there containing images for both of these. Model registry, that is a key value store containing these serialized versions of the model objects and the proper metadata for that. Then there's optional parts like this model validation service and then this automatization service that is needed if this validation service actually fails, so that it recognizes something is not right there. The input data has significantly different properties. Then we can start even notify the users, start the retraining of models, so on. And then one thing that is really important here is that this doesn't dictate anyhow what's the implementation of these individual components. So that currently it is so that all the major cloud providers, they provide these their own versions of these components, especially this model handling. It is something that is rapidly developing area. There's rapid changes in the product roadmap, so it would be a little bit risky to build the whole company functions based on the single thing. So that is that we have how we handle this. We have this kind of control endpoint in each research group, and this control endpoint has access to all of these components, and then it also discusses with this kind of Stora Enso AI management service. That is practically the web portal where you can see all the services, all the models, what kind of data goes into the models, things like that. So it's actually a window for the service owners to see what is happening there. Okay, then I'm ready to conclude my presentation. The key point was that provide this kind of company-level visibility to AI-based services, models and the data. It is especially if you are dealing with services that control in some real systems. I anticipate that in the future there will be even some kind of auditing things. So it's a very good idea to have a visibility to these things in the centralized way. The next thing is, because it's true for all data-driven organizations, that they make their data easily available for developing these new services that depends on the data. Then separate the service logic and the models. Otherwise, it will be mess if you have a lot of hundreds of different services that contains the statistical models. And then remember these statistical properties. So consider adding validation service between this actual service logic and the models. And this concludes my presentation. Thank you.